Welcome to It's STO Simple. This is a educational tutorial on the use of solo timed observation, or what I call STO, in determining Earth's true surface shape. Thanks for watching. What is solo timed observation, or STO? It's the simple act through visual lines of orientation, first from 90 degrees to an object from the observer. This initial observation starts the designated time, and that's going to be we're going to have 3-hour time mark. Then measure the angle of the reading from 90 degrees to the object at the designated elapsed time to record angle. This test will be again at the 3-hour sun time mark, which is equivalent to the 45-degree curve for the globe model. So we're going to check for that curve to see if it's present. The learning objective. This is a knowledge sharing educational tutorial on the use of STO, triangulation methodology, using direct sun angle to determine by direction, distance, location, Earth's true surface shape. Additionally, to determine sun's actual distance. And when we apply STO, we're going to apply it to the globe model and the flat Earth model. And what I want you to remember, that the flat Earth model has a full 90 degrees to work with when we're measuring up to the sun, or the sun is 90 degrees to us. The globe model has a slight disadvantage. They only have 45 degrees to work with, to measure with. Why? Because they lose 45 degrees in the curve. So that's a slight disadvantage to the globe. Just keep that in mind. And it's as easy as counting 3, 4, 5, or 3 sun hours equals 45 degrees. Just keep that in mind. That's one of the big things I want you to remember, that the sun movement is 15 degrees an hour. So we're going to test that 45 degree sector, and we do that at the 3-hour mark. And how do we break those sectors down? Here on the globe model, we have 8 sectors, or 8 45-degree sectors. Mostly what you find on the internet. The globe, what they say, the circumference is about 24,901 miles. And each sector is just a little bit over 3,000 miles. And we'll break that down into each 3-hour section, or 45-degree sector. Remember, again, as I said, sun movement is 15 degrees an hour. Ideally, we'd like to be along the meridian to do these observations. And we have, if you don't know what the meridians are, we have 3 prime meridians. We have the Tropic of Cancer in the northern hemisphere, and then we have the equator, which is the central meridian, and then we have the Tropic of Capricorn in the southern hemisphere. And again, you want that observer to be on one of those meridians when the sun is located optimally at that location. And for example, the Tropic of Cancer in the northern hemisphere would be 21 June 2000. This year, the sun is going to be directly over that meridian. So that observer, if they were located on the Tropic of Cancer, you first start your observation at the 90-degree mark, then 3 hours later get your measurement, and you'll find out your surface angle real quick from that measurement. And what's the effect of the sun if you're the effect of your reading if you're off one of those meridians? As I said, you can do this anywhere in the world, but then you're going to have effects which can alter your reading. To give you an example, we're in Kabul, Afghanistan. So we are right now, the sun is in the southern latitude to us from 90 degrees. So we'll get an angle reading a little less than what we should get if we were located along a prime meridian when the sun is located along that prime meridian. So just take that into consideration. And the same thing would happen if you were in the south, in the southern latitudes, and the sun was to your north. Same effect. And just for this example, I've used from the 90 degree or mid-noon, that sun could be 85 degrees or 5 degrees difference off of a perfect 90-degree angle. So that would affect your reading. You wouldn't get a real true reading, just to keep that in mind. And some people will mistake this as a curve, and it's not. It's just sun location. And what's the real objective here? The real objective is, I coin it, taking the black queen, or removing the heliocentric model long distance game piece off the board, and that's the black queen. If you're familiar with chess, you know that queen can do a lot of damage long distance wise, and it can move anywhere on that chessboard. And we want to bring that sun back in from what science says is 93 million miles back into just a little over 3,000 miles, and we can show that used through STO. Very simple. Our ongoing operation, Operation Resolute's time, we initiated in February 2000. We started measuring sun angle, and we've got some pretty significant findings as a result of significant angles at, we're just under 6,000 feet to the sun in May, readings that exceed just over the 50-degree mark at the 3-hour timed STO observation event. In other words, a solo timed observation event. The significance is that if we apply these readings to the globe model, the Earth's said curve does not show. If the Earth's curve were to be present, readings should be in the high 30-degree to low 40-degree range at the 3-hour mark during this time, and that's what it should really be. And again, it's up in the 50s, with the peak reading near 45 degrees on or about 21 June 2020. This is not the case with the current readings exceeding 50 degrees. So again, from our readings up here in Kabul to the sun, the curve is not showing itself, or the curve is not present. We've exceeded 45 degrees. I've had to develop a handy device I call the Marx device, and this positioning device, we can position it over our survey point, or point of observation, where we want to start our observation for the sun. And this is really critical. We need to know where our point or our axis of observation starts when we start observing the sun. And this device can be shifted into different designated locations. Ideally, we want to be close to noon as possible. We don't have to be at noon, but ideally we want to be close as possible. Again, and this device is a small piece of wood with a center hole and some lines strung across the center, and the line casts that shadow and gives us a perfect 90-degree north-south grid line. And this object is, or this device is oriented north. It's oriented north. And again, this can be shifted in different locations. And just to show you what it actually looks like, again, this is a 6 by 18 inch piece of cut plywood. There's a center hole cut in at about 1 inch. You can fit a bottle cap through the center of it, or just to be able to identify your survey point marker on the ground. You set that center mass of that, orient it north, and when the sun casts its shadow on it, it'll move that shadow, and then when the sun is 90 degrees position, that shadow line will be center of that cut hole piece, or right over your survey point. Very effective and efficient tool. And I said this can be moved around to where you want on your survey points, but keep it oriented north. STO and the globe model. Just to go over the STO and the globe model real quick here. Again, 90 degrees is our angle that we work with, and that 90 degrees is from the observer to the sun, or the end of the orienting line. So we have up to 90 degrees measurement. Now remember, on the globe model, we lose 45 degrees on the curve at the 3-hour mark. So we only have 45 degrees to work with. And once we hit 45, we're in lines of parallel. Okay. If you believe you can see 93 million miles, and your ultimate reading is 45 degrees, or line of parallel directly into the sun. And again, our elevation right now is just under 6,000 feet, but ideally you want to do this at or near sea level, right about 1 meter. And again, any reading that exceeds 45 degrees means no curve. And here's an example. If we exceed that 45 degree reading, if we go into the 50s, which we are right now, we get a reading of 55 degrees from the observer. That puts us over 10 degrees and puts us at 100 degrees total reading. It exceeds the 90 degree mark. Remember, the total composite reading cannot exceed 90 degrees. We only have 90 degrees to work with, especially on the globe model. And what happens when we exceed it? this is what happens in, again, this is what I talked about. The observer is observing on the sun's center mass, so we're using half sun width. When you get that reading of 55 degrees, now that reading is 10 degrees off center mass of the sun. In other words, you're no longer line of parallel. You're outside that tolerance by 10 degrees. What that means in distance-wise, and this is similar to U.S. Weapons bore sighting. When you bore sight weapons, the U.S. military uses this, and it's a very effective tool, bore sighting. You are now off sun target by 16.5 million miles. And if we use sun half width, you're just off by 16 million miles. So not only are you not in the right area code, you're not even in the right phone book. So you're not looking at that object. And again, this is how we can tell if there's really a curve and if there isn't. And this tells the tale. Black and white, pretty easy. How do we get this distance? We use a right triangle calculator, right triangle data calculator. And all we do is we plug in our information. We plug in sun distance, what science has told us, and we plug in the angle, what we were over on our angle from parallel, in which we were 10 degrees over, and that gives us a result of 16.5 million miles off sun target. So it's just a simple triangulation, and again, simple geometry. And then finally, to get the true measurement off of the surface of the Earth, or the sun angle to the from the surface of the Earth, right now we're taking measurements from 1/2 meter and 1 meter, and what we're finding out is that it's only a difference of 1 degree. So what we do is we take the measured 1/2 meter angle measurement, and we add 1, and that gives us our true reading to the sun angle to the sun from the Earth's surface. And as a result, the Earth's surface is flat. Again, this has been the educational tutorial on STO, triangulation methodology, doing a solo timed observation event to the sun. If you have any questions, you can email me at coryifish@gmail.com. Thanks for watching, and stay safe out there.